Hi everyone, and welcome to our video on evaluating compositions of inverse and regular trig functions using no calculator. We'll find the exact value. All right, so it mostly is just using the order of operations, kind of like, so we did these problems in a different video. You work with the inner and then go to the outer. All right, so in these first three, we have a regular trig function inside the parentheses. I'm going to mark those in blue. So cosine of pi 6, so we just do that, cosine of pi 6. So cosine of pi 6 is, let's go vertical with it. So we have cosine inverse. Cosine of pi 6, so we can draw our unit circle. I'm going to draw it a little small. And we know that that puts us close to the x-axis, and it gives us our radical 3 over 2 and 1/2. So it's saying cosine of pi 6 is radical 3 over 2. And then now we have to do the cosine inverse part. I'm going to draw that a little bigger because I want to mark it. Cosine inverse, remember, has to be between 0 and pi. Okay, so that means this answer, again, this is an x-coordinate, the radical 3 over 2. Well, you got to look above. There's where radical 3 over 2 is as an x-coordinate. And then working backwards, I know that that's the angle with pi 6. Okay, so cosine inverse of radical 3 over 2 is just pi 6. So this problem, we could have also used the rule that we saw for 1 and 2 above. It happens to work out. Again, I would go the long way because it doesn't take much longer and it's guaranteed to give us the answer. Don't fall for a trap. Okay, so we're going to see what happens here. So you might say, oh, can I just do this right away on this problem? Well, let's find out. Let's find out. Okay, so I'm going to scribble that out. So still break it down and do this part. Okay, so the cosine of negative pi quarters puts us down in quadrant 4. Okay, so we went down to quadrant 4 there, and then we know that that point is radical 2 over 2 and radical 2 over 2. Oops, negative. Okay, so the x-coordinate's what I wanted because it's cosine. So we know all of that in the blue is the square root of 2 over 2. And then I still have the arc cosine hanging out. So I need to do the arc cosine of radical 2 over 2. And I'm going to draw a sketch for that and mark it in blue just like I did the previous problem. I know arc cosine is an angle between 0 and pi. Radical 2 over 2 is an x-coordinate. So this is an x-coordinate where I have a positive x-coordinate in this region that's marked in blue is in quadrant 1. And then we know, well, quadrant 1 with an x-coordinate of radical 2 over 2 is pi quarters. Okay, so our answer then for this problem is pi over 4. Okay, so that's why we break it down with the order of operations. Notice again, I scribbled it out. If we're using the rule that we used from number 1, we would have gotten the wrong answer. It is not negative pi over 4. The final answer is positive pi over 4 because arc, cosine, and all the inverse trig functions have special ranges. We got to make sure that we're in the right range for our final answer. All right, number 3. Number 3, we have arctan of tangent of negative 4 pi thirds. All right, so still order of operations. Let's sketch that out on our unit circle. All right, negative 4 pi thirds, you can convert it to positive 2 pi thirds if you want. So you could use coterminal angles, whatever you need to do to make sure you get it. But because it's a 3 in the denominator, I know it's one of these 4 that's close to the y-axis. Negative 4 pi thirds would put us, you can't really see it in the blue, let me mark it in red, would wrap around and put us in quadrant 2. Okay, again, or if you did 2 pi thirds, it puts us there still. Okay, so we've got a 3 in the denominator, arctangent, or tangent of negative 4 pi thirds. 3 in a denominator means we have negative 1/2 and positive radical 3 over 2 as our terminal point. dividing my y coordinate with my x coordinate, we do get negative radical 3. Okay, so we have arctan of negative radical 3. Now arctan, again, the inverse trig or arc trig puts you in special ranges. We must be between negative pi halves and positive pi halves for an answer. Arctangent of a negative number must be a negative angle. I see 1, 3 only. So that means I should have something with a 3 in the denominator. Was a nice little trick we discovered. And so that puts us at negative pi thirds. Okay, so arctan of negative radical 3 is negative pi thirds. So again, notice our answer is found using the order of operations. It wasn't negative 4 pi thirds. So again, if you said, oh, doesn't arctan and tan just cancel each other out? So shouldn't this just be instantly negative 4 pi thirds? No, that's not what we got. That's not the same thing. Okay, so careful with these. Just do your order of operations. So it's like kind of 2 unit circle problems in one. All right, the difference between those first 3 and these bottom 3 is that our inverse trig is now inside. So it's still order of operations. Okay, so still just breaking it down. Let's mark this in blue. Okay, so this time it's cosine inverse. So cosine inverse must be between 0 and pi. So our answer has to be there. That 1/2 is a x-coordinate. A positive 1/2 x-coordinate puts us close to the y-axis at pi thirds. Okay, so that means this becomes sine, let's keep that in blue, of pi thirds. Okay, so sine of pi thirds, now that's just a regular unit circle problem. Sine of pi thirds, I mean, I drew a new picture, but don't really need it too much. There's the angle. I didn't mark the actual terminal point in the previous step. I just marked the angle. But sine of pi thirds wants the y coordinate. So this final answer is radical 3 over 2. Okay, so again, it's just kind of break down piece by piece, use the unit circle multiple times. Okay, so now let's do these last 2 here. So sine inverse of negative radical 3 over 2. Again, I'm going to draw my unit circle, the whole thing. However, it's sine inverse, so that means I know it should be between negative pi halves and positive pi halves. So that's where sine inverse must lie. Negative radical 3 over 2. Okay, so it's a y coordinate. Negative radical 3 over 2 would be close to the y-axis. Okay, but I go clockwise to get there, and that would be negative pi thirds. Okay, close to the y-axis, so that's our one with the 3 in the denominator. Okay, so all of that in the blue parentheses, let me bold it one more time, is the angle negative pi thirds. So this becomes tangent of negative pi thirds. Now, one last time here, so kind of breaking the room, I'm going to get my answer box ready. Tangent of negative pi thirds. So negative pi thirds is still right here with the terminal point 1/2 and negative radical 3 over 2. Well, again, dividing my y coordinate with my x coordinate, that would give me negative radical 3. Okay, so that would be our final answer for this problem. Okay, and one last one. Secant of tangent inverse of negative radical 3 over 3. All right, so still bolding it in blue. Let me put the secant here right now so I make sure I have enough room. So secant of this answer. Okay, so that in the blue, so I don't think I can squeeze it down the below or to the side. So I'm going to put it down below. Okay, so tangent inverse, again, one more time. tangent inverse must be between negative pi over 2 and positive pi over 2. So it must be somewhere in there. It's negative radical 3 over 3, so that must mean it's in quadrant 4. I see two 3's involved, radical 3 and then regular 3. Remember, our little trick there is to add them up, and we would say, well, that should have a 6 in the denominator then for our angle, but it's in quadrant 4, so it should be negative pi over 6. And let's write out our official point as well. Okay, so positive radical 3 and negative, or positive radical 3 over 2 and negative 1/2. Yes, when we divide the y coordinate with the x coordinate, that would give us the correct value. Okay, so that means all of that right there is negative pi 6. And then now we just have to do the secant. Secant of negative pi over 6. I'm going to use this picture again. Secant of negative pi over 6 is focusing on that x coordinate. But remember, secant is the reciprocal of cosine. So we would flip that answer. So this becomes positive 2 over radical 3. And then we can rationalize it real quick by multiplying both the top and bottom by radical 3. So our final answer is 2 radical 3 over 3. Okay, so that's how we do these compositions. Thanks for watching. If you have questions, please let me know.